Hi crew, these are our next notes for solving triangles. So we looked at the law of cosines and how we could use the law of cosines, and today we're going to look at the law of sines, which is going to help us out in a different situation. So back in geometry, we learned that we could identify parts of a triangle using an S for a side and using an A for an angle. And we would list those in order of what we knew. So, for example, if we had SAS, we knew that we had information about a side of a triangle, an adjoining angle, an angle that butts up right next to that side, and then the adjacent side of that angle on the other side. So we had two sides and the angle in between. So we're going to use those same type of abbreviations to summarize the parts of a triangle we know when we are solving a triangle, which again means to find all the parts of that triangle. So here we go. If I know side, angle, side, then I know a side of a triangle, an angle, and then the next side. So I've got the two sides of an angle. That would be side, angle, side. I know angle, side, angle. If I know an angle, I know a side next to that angle, and then I know another angle. So this is angle, then side, then angle. So the side is in between those two angles. I know angle, angle, side if I know two angles of a triangle, and then a side that is adjacent to one of those angles but not another. So this is not an angle not a side in between the two angles, but beyond those two angles. I know SSA if I know two sides and then an angle. So if I had side, side, and then an angle, so the angle is not in between the two sides. And I know side, side, side if I know all three sides of a triangle, and I know angle, angle, angle if I know all three angles of a triangle. So just to remind you of what that means, we're going to use that notation. Okay. Now, the law of cosine said that a squared equals b squared plus c squared minus 2bc cosine of an a. So this a is a side, this b is a side, this c is a side. And then we know a, which goes inside of a cosine, and that is an angle. So this law of cosines involves three sides and one angle. Remember, right, just good review, that the side we put on one side of the equal side and the angle that goes in the cosine are opposite to each other. Right? So the only way we can use law of cosines to solve a triangle is if only one of those four parts is unknown. So since we have three sides and an angle, for us to use the law of cosines, we're going to have to know at least two of those three sides in order to solve that triangle. So the situations where we could use the law of cosines are side, angle, side, because we have two sides, side, 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 because we have two sides and then the third, or side, side, angle, because we have two sides and then an angle. In our previous homework, we've already solved triangles where we knew an angle in between two sides and three sides using the law of cosines. We'll look at this side-side angle situation in our next set of notes. We're not going to look at those today. So what's new to know is this. If we need to solve a triangle where only one side is known, so we either have angle, side, angle, one side in between two angles, or angle, angle, side, where the side is not in between the two angles, but outside of those two angles, right next to one but not the other, we need a new formula, and that formula is going to be the law of sines. That law of sines says that the ratio of the sine of one angle and the side opposite, so again, right, these are opposites to each other, will equal the ratio of the sine of another angle and the side opposite of that. So when we use this law of sines, we basically use, right, we write a proportion. We set two ratios equal to each other. So we wouldn't write all three proportions, all three ratios. We would just pick two of the three based on what we know. So if we flip those over, this one here says if we take the ratio of a side over the sine of its opposite angle, so again, right, this is an angle and a side that are opposite of each other, that will equal the ratio of another side over the sine of its opposite angle. And again, we would only use two of the three, right? It could be any two of those three. In general, we are going to use this form of the law of sines, right? We're going to use this to find an angle when we know two sides of a triangle, right? So if I'm going to use this to find an angle, I would need to know two sides and then the angle opposite one of the other sides, right? But we already can use the law of cosines for that, which is actually better in the long run. So if we use this form, we're going to use that form to find a side, right? And we prefer this form to find a side because the side is on top of the fraction when we know two angles. So if I wanted to find side B, I would have to know the angle opposite that side. I would have to know another angle, and then the side opposite that angle. So in general, I'm going to erase, well, I'll do that. But in general, we are going to use this form only, or almost only, and we will use that form when we know two angles and we want to find a side. So I'm not going to prove that law of sines, but we will go over this. To use the law of sines, we're going to identify two known opposite parts. So that would be a side and its opposite angle. We're going to determine to find the part opposite the third known part, right? So that would be a known angle, and we want to find the side opposite that angle. We're going to use the proportion then that involves your known parts only. And then we're going to use the form of law of sines that has that unknown part in the numerator. So let's look at an example of that. In triangle ABC, so I'm just going to draw a triangle. This is not necessarily to scale. And I'm going to label that with the angles in order, A, then B, then C. I am given that angle B is 64. So I'm going to label that 64 degrees. That angle C is 38, so this is 38 degrees. And side B is 9 feet. So side B is opposite angle B, and that is 9 feet. And my job is to find the lengths of A and C. So I need to find what A equals, and I need to find what side C equals. So I've drawn my picture. I want to identify my case. What do I know? I know an angle, and then another angle, and then a side. So my case is angle, angle, side. So when I have angle, angle, side, I'm going to use, right, angle, angle, side says to use my law of sines. So for me to use my law of sines, I'm going to start with a ratio that involves the two opposite parts that I know. So I'm going to say 9 over the sine of my angle, 64 degrees. And I'm going to set that equal to, and I want to start with the angle I know, which in this case is C. And I'm going to write the ratio that is its opposite side, which is C, which I'm trying to find, over the sine of 38 degrees. So for me to find how long side C is, I'm going to multiply both sides by the sine of 38. So I'm going to multiply this side by the sine of 38, and I'm going to multiply this side by the sine of 38 degrees. And I end up then from here, I end up with C equals, right, what this equals, which if I put that in my calculator, remember I'm in modes, I get 6.165, and that would be in feet. For me to find how long A is, right, for me to find what A is, I would need to know what angle A is. Well, I know that, right, the measure of angle A would equal 180 minus what 64 and 38 are together because the sum of the three angles has to equal 180. So I solve that and I end up with A is 78 degrees. So for me to solve for A, I'm going to say A, side A, which I don't know, over the sine of angle A, which is 78 degrees, will equal, I'm going to go back to B, 9 feet over the sine of 64 degrees. I solve for A by multiplying both sides by the sine of 78, and I get A equals 9 times the sine of 78 over the sine of 64. Put that in my calculator, and I get 9.795 feet. And we have used the law of sines to find A and C. Okay, squeezed all that into that space and didn't need it. All right, so here we go. In triangle ABC, next example, I'm given some information. So I'm going to come in here and I'm going to draw ABC. Again, I'm not worrying about drawing that to scale, though it would be kind of helpful to do that. It helps us see what's going on. But in this case, angle B is 64 degrees, angle C 38 degrees, and this time side A, which is opposite angle A, is 8 meters. And we're trying to find sides B and C. So we come in here and we're going to look for our case. What we know is angle, then side, then angle. So we know angle, side, angle. Right? 2 angles in a side means I'm going to use law of sines. My problem here is that I don't have any parts known that are opposite to each other. But I know that I can find the measure of angle A. So the measure of angle A is 180 minus the sum of 64 and 38, right? The sum of the 3 angles of a triangle have to equal 180, which gives me that the measure of angle A is 78. We had that in the previous example. So now I know that this angle is 78 degrees. Wasn't given to me, but I can find it. And then I can set up my ratio using side A with angle A. So if I'm going to find side B, then I would say B is to the sine of 64, right, angle B, here's side B opposite angle B, as 8 is to the sine of 78. Notice I've got sides on top, I've got sines of angles on the bottom. Solve for B, and I get B equals 8 times the sine of 64 over the sine of 78. Let my calculator evaluate that, and I get B is about 7.351 meters. For me to find C, I'm going to set that up very much the same way, and I would say here, C is to the sine of 38, right? C is opposite my 38 degree angle, as 8 is to the sine of 78. Solve that for C, and I get C equals 8 times the sine of 38, right? Multiplying both sides by the sine of 38 over the sine of 78. Evaluate that, and I get C is 5.035 meters. Remember to go out 3 decimal places when you round, and include units when you have that information. Okay, that is it for today. You're going to do problems tonight that use this. The ambiguous case we will cover tomorrow in class.